Fill in the blanks. Sound is generated by the rhythmic dash of any object. Vibrations. The frequency of sound is measured in dash hertz. If dash of sound is decreased, its loudness also decreases. Intensity. A medium is necessary for dash of sound. Propagation. Match the pairs. Flute. Vibrations in the hair. Frequency measured in hertz. Sound level decibel. Ultrasonic sound frequency more than 20,000 Hz. Infrasonic sound frequency less than 20 Hz. Give scientific reasons. In earlier times, people used to listen for the arrival of a distant train by putting their ear to the rail. While the train runs on the rail, its wheels bang on the rail and friction occurs. These banging and friction produce vibrations and sound is produced. These vibrations propagate to a large distance through a solid medium such as rail. That means the sound travels over a large distance through rail. If ear is put to the rail, this sound can be clearly heard and the arrival of a train can be guessed. Thus, in earlier times, people used to listen for the arrival of a distant train by putting their ear to the rail. The sounds generated by a tabla and a sitar are different. The stretched diaphragm of a tabla, when struck, produces vibrations which generates the sound. The stretched string of a sitar, when plucked, produces vibrations which generates the sound. In this way, due to the difference in the vibrating object, the frequency of vibrations from both the objects is different and the pitch of sound is also different. Thus, the sounds generated by a tabla and a sitar are different. If you are both on the moon, your friend will not be able to hear you call. Medium is necessary for the propagation of sound. There is no atmosphere on the moon as that of the earth, and thus due to absence of medium, sound does not propagate while talking on the moon. This is the reason why your friend will not be able to hear you call. We can hear the movement of a mosquito's wings, but we cannot hear the movement of our hands. Humans cannot hear frequency less than 20 Hz. In the movement of hands, oscillations does take place but is less than frequency that humans can hear. Mosquitoes' wings flap in air. When they fly in air, it produces buzzing sound in our ears. The movement of mosquito wings produces sound greater than 20 Hz. Sound is the reception of such waves and their perception by the brain. Write answers to the following questions. How is sound produced? Sound is generated by the rhythmic vibration of an object. We can hear the sound as long as the object vibrates. Vibrations are produced in an object when it is struck. Vibrating object is the source of sound. The rhythmic vibrations of an object produces food. What does the intensity of sound depend upon? The intensity of sound is proportional to the square of the amplitude of vibration. Example, if the amplitude is doubled, the intensity of sound becomes 4 times. Therefore, the loudness or softness of sound is dependent on the intensity of sound and sound level. Explain how the frequency of oscillation is related to the length of a pendulum and the amplitude of its oscillation. As the length of a pendulum increases, the frequency of oscillations decreases. That means, as the length of a pendulum increases, the number of oscillations in 1 second decreases. The frequency of oscillations is not affected much by the amplitude of oscillations. That means, even if the amplitude is increased, the frequency does not change much. It remains nearly the same. Explain the two ways by which the pitch of the sound generated by a stretched string can be changed. A string vibrates with a particular fundamental frequency. It is, however, possible to produce pitches with different frequencies from the same string. The two properties of the string that affect its frequency are length and diameter. When the length of a string is changed, it will vibrate with a different frequency. Shorter strings have higher frequency and therefore higher pitch. When a musician presses her finger on a string, she shortens its length. The more fingers she adds to the string, the shorter she makes it. Higher will be the pitch. Diameter. Thick strings with large diameter vibrate slower and have lower frequency than the thin ones. Use your brain power. Will a sound be produced no matter how the ruler is kept on the table? A plastic ruler is placed on the table such that its one hand is on the table and the other hand is off the table. Pressing the hand on the table, if the other free hand is pressed in downward direction till the ruler slightly bends and then the free hand is released. The vibrations produced in the ruler and sound is generated. Now find out using your brain power, will a sound be produced no matter how the ruler is kept on the table? If you perform the same activity by placing the ruler at different positions and distances onto the table, you will see that sound is not produced by placing the ruler in any position. If the ruler is placed straight or erect on the table, then the sound is not produced. If most of the part of the ruler is on the table and only a little part is out of the table, then the vibrations are not produced in the ruler and thus the sound is not produced. Is there any correlation between the length of the free part of the ruler and the sound produced? The length of the free part of the ruler and the sound generated are related to each other. The sound coming from the ruler changes according to the length of the free part of the ruler. If the ruler is plucked while it is held with 25 cm of it off the table, does it make any sound? If there is no sound, look for the reason why it is so. If the ruler is held with 25 cm of it off the table and is plucked, it does not produce any sound because the frequency of vibrations produced that time would be very less. We can only hear sounds of particular frequency. Which of the sounds, the roar of a lion or the hum of a mosquito, has the higher pitch? If the roar of a lion or the hum of a mosquito is compared, then the roar of a lion is loud, more intense, but is of lower pitch. On the other hand, the hum of mosquito is soft, less intense, and is of higher pitch than the roar of a lion. What structures in the sitar help to produce higher or lower pitched sounds? Sitar has two structures. One is a gourd shaped and other is long neck. The free hand at the upper side of the long neck has many nails to roll the string. 7 strings are attached from the nails to the gourd. There are membranes below these strings. The tension in the strings can be increased or decreased by adjusting the nails. With the help of these structures, the higher and lower pitched sounds can be produced from the sitar.